Flight 142's Ariane 5 is on the launch pad. The operations for tonight's launch have been going on since 8:30 this morning. The main cryogenic stage has been filled. The Vulcan motor has been chilled down. The launcher is waiting on the launch pad for the synchronized sequence and a launch in 13 minutes.
Greetings, everybody, wherever you may be, and welcome to Kourou. Welcome to the broadcast booth. Here we're at the home of Ariane for tonight's live broadcast of Ariane space flight number 142. My name is Joshua Jampel. With me is Luca Kekio, my friend from Ariane Space Operations side. Hi, Luca.
Hello, good evening, and buonasera a tutti. For Ezrin, Frascati, NHK Tokyo, OSC Virginia, Singapore, Washington, D.C., and all the other European sites listening to us tonight.
Luca and I will have the great pleasure to be with you all for the next hour, roughly, as we call out the highlights and the milestones of Flight 142, the mission tonight, through the final moments of final countdown and liftoff, and up until satellite separation. Luca, we have two satellites tonight.
Yes, tonight we have two satellites, two telecommunication satellites, Artemis for the European Space Agency, and BSat-2b for Japanese BSat.
All that's coming up. Take a look first at the mission summary to give you an idea of what's ahead, and you'll meet your French commentators. We'll be back. Tonight in Ariane 5, we'll put two new satellites into geostationary transfer orbit, Artemis and BSat-2b. Highlights of the show and the mission include a visit to the Paris Air Show, where we announce some new contracts. We'll then follow all the key milestones of Ariane space flight number 142, including the launcher campaign for the Ariane 5, which went, as usual, right on schedule. The same can be said for the two satellite campaigns for our passengers, the European Space Agency for Artemis and Orbital Science Corporation, builders of BSat-2b.
Larger buildings for the
We'll have a special report on the new S5 satellite preparation buildings. That's coming up in positive time. And finally, some live interviews with our special guests right after the launch.
Merci de nous retrouver ici dans la cabine assurant les commentaires en français. Avec moi, Patrice Larcher pour tous les commentaires techniques. Bonsoir, Patrice.
Bonsoir.
Voilà, on va vivre de grands moments puisque notamment le décollage va se faire en plein jour tout à l'heure. Et c'est une Ariane 5, Patrice, qui assure la mission de ce soir.
Oui, ce soir, ce sera d'ailleurs le 7e vol commercial d'Ariane 5. Et nous assurons la mission pour le mettre sur orbite pour le compte de deux clients. L'un, l'Agence spatiale européenne, qui va lancer Artemis, que l'on voit d'ailleurs l'ensemble du lanceur Ariane avec son composite supérieur.
Là, ce sont les images très belles. Hein. Hier, c'était il y a 24 heures du transfert d'Ariane.
Et qui ont été prises hier pour le premier satellite Artemis pour le compte de l'Agence spatiale. Et c'est un satellite de télécommunication expérimentale. Le deuxième, c'est BSat, pour un opérateur japonais pour effectuer de la télévision directe.
Dans 5 minutes maintenant, le directeur des opérations va annoncer le début de la séquence synchronisée. Restez donc avec nous. Tout d'abord avec vous, Patrice, on revoit cette mission du vol 142.
The Ariane 5 vehicle was transferred yesterday from the BAF, the final assembly building, to the launch zone, with its two passengers fully integrated. Ariane 5 is now waiting for completion of the final countdown. Flight 142 will place its two payloads, both communication satellites, into geostationary orbit. They'll eventually be positioned at 22,000 miles, or 36,000 kilometers, above the equator. Passengers tonight are the experimental satellite Artemis for the European Space Agency in the upper slot, built by Alenia Spazio, and BSat-2b, a direct TV satellite for Japan, built by Orbital Science Corporation. Right, well, launch opportunity, it says up here, that I think means the window. They don't really say how long the window is, Luca. Do you know anything?
Well, tonight's window is 1 hour and 33 minutes, which is a pretty long window for a geosynchronous orbit.
What's the average?
The average is about an hour, but that depends from the clients.
So we have plenty of time. We're in no hurry. Tonight, all is green. We're counting down for liftoff.
We have a very nice view of Jupiter, which is a launch basis control center here. And but stay with us and let's look at the last news from Arianespace.
As usual, Arianespace had a high-profile presence at the 44th Paris Air Show last month. The event, held at the historic Le Bourget Airport outside Paris, was the perfect occasion to announce the signing of 8 new launch contracts with European and American satellite operators. This means orders are right on target for the year, since halfway through 2001, Arianespace is on schedule toward its goal of booking over a dozen new contracts. This month saw the retirement of Daniel Meunier.
Avec Ariane, parce que si j'ai fait 20 ans avec Ariane Espace,
I spent 40 years with Ariane Space altogether because I spent 20 years with Ariane Space and CNES, but the first 20 years before that were in industry, where I worked on Ariane's third stages from Ariane 1 to Ariane 4.
40 ans.
It's been 40 exciting years, during which I worked on all the successive developments from Ariane 1 to Ariane 5, Ariane 5 being the one I was busiest with, of course. But there comes a moment when you have to know when it's time to go. My successor has been named. Edward Perez will replace me, and David Cancard will be replacing him, and everything is going to work out fine, I'm sure. Tomorrow sees inauguration of the new S5 satellite preparation buildings here at the CSG. The new complex was designed to better serve our customers and offer a one-stop shop to future builders and operators. You can see what the weather looks like. We are due for a spectacular launch because the sun, I don't think, will be down. We should have a lot of light from the liftoff. The Ariane, where she is now, is a little farther to the northwest than where we are here in Jupiter. She's up at what they call the CDL, right? Look, that's a launch.
Well, she's up in the on the launch pad, the LA3 launch pad, which is around 12 kilometers off from Jupiter, and it's controlled from the launch center by the COELS team, or the launch team. Now, this is the image of Jupiter, though.
Because there are several teams. This is the range operations manager, so-called because there are a lot of operations on the range, and the CDL is just one of them. We'll get back to that in a moment. But the Jupiter, where we are, is the real nerve center of the space base, where there are some 1,400 people scattered about doing different jobs, all sending their information in here to that DDO. And like I say, we'll get back with an explanation with Luca in just a minute. We are going to be hearing in just about 18 seconds at the 7-minute mark, the minus 7-minute mark, you hear the DDO, this man, calling out the 7-minute mark for what we call the synchronized sequence. Coming up.
De DDO, attention pour le début de séquence synchronisée. Top, H-7 minutes.
So with a little microphone noise, we got a top with the minus 7 minutes. We're now into what we call the automatic sequence, which means what?
Which means that in this last sequence, there is a great number of operations, and delicate operations with very precise timing to be done. Hazardous operations that have to be done at the very last moment. Well, these operations have to be carried out by the CDL, by the COEL and his launch team. They are carried out by 2 software programs running on the operational control computer in the CDL.
2 programs, but 1 computer.
2 programs, but 1 computer. One does all the fluid activity, and the other one, all the electrical.
Now, this is different, isn't it, from Ariane 4, where you have 2 different computers, one for the fluids and one for the electrics?
That's right. In Ariane 4, we had 2 different systems with meeting points between each other. In this case, we still have 2 softwares, but on 1 computer.
So it's a big improvement.
Yes, it's much more integrated improvements.
Right, 6 minutes. What else can we say about synchronized sequence? What else is going on right now?
Well, what's going on right now? At this moment, the synchronized sequence is topping up and pressurizing the liquid oxygen and liquid hydrogen tanks. It will be arming the launch vehicle at minus 6 minutes, switching to onboard power 50 seconds before, and start the ignition sequence. Then at minus 6 seconds, it will begin what we call the irreversible operations. That is lighting the Vulcan hydrogen fume systems. Then the onboard computer will take over, which means the launcher will take over the operations at minus 3 seconds. At H0, we open the liquid hydrogen latch valve, or the chamber valve. We then have ignition.
Okay, that's briefly synchronized sequence. We have some more time. We'll get some more details for you. You're looking at the green status panels, which is what everybody here in Jupiter is looking at. They're up on the wall here. And green means everything is going okay, right? You want to take us through these?
Right. So these tables have the different systems and their status. If they are green, it means that the system is go. As an example, we have a telemetry or localization. Telemetry, well, the launcher is automatic.
Telem is 0, that's on the bottom, third from the bottom.
That's right. So when the launcher will go up, it will send back data back to Earth so that we know what state it is and if everything is going well. This data will be relayed to ground stations, that is Galileo here in Kourou, that will be Natal in Brazil, Ascension Island, and then Malindi. And if all the stations are good, have a good status, they will send the information that they are ready, therefore they are green.
So we mentioned that there are these over 1,000 people working excuse me, across the base all working at these different systems and sending their information in here to the DDO, who interprets this information, synthesizes it into a go, no-go, or makes the decisions, or how does that work?
That's right. So all the systems send their information or their status to the DDO. And the DDO gives the authorization to launch if all the systems are go. So if one of the systems, like Meteo, which is the weather, shows that there's a problem, that there might be a big thunderstorm.
That's Meteo, that's on the bottom left of the screen.
In that case, that system would go red, and then the launch operation, range operation, would not give authorization to launch.
And in the case of a red, we have to put the entire configuration back to the beginning of synchronized sequence and go back to -7 minutes.
That's right. In case of a red, we have to start the sequence again. So that means that we have to reconfigure the whole system, put in a stable configuration, and go back. Now what we have here is what we call the flight directorate. This is Monsieur Jean-Marie Luton, the CEO of Ariane. He is part of this little group of people who will take the big decisions in case of any problems. On his side, Monsieur Jean-Marcel Agasse from the Operations Directorate.
This is the Ariane Space, the Flight High Command. They're involved in any big decisions that have to be made this evening.
That's right. And on his side, the Technical Director, Mr. Edouard Perez.
You can see behind them some of the VIPs and the invited guests who are sitting on the other side of the glass fishbowl, where the operational people are in. Didier Cassé.
Didier Cassé is the chef de mission, which is the Ariane Space mission manager. He works with the DDO and in his interface with Ariane Space and the clients with the DDO.
And speaking of the clients, the men from Alenia.
Speaking of the clients, here we have Mr. Morelli and Mr. Mastracci.
Didier Cassé again.
Didier Cassé again. So Mr. Morelli and Mr. Mastracci are there for Artemis. And Mr. Mike Kalari, which is the RCUA responsible for the contract of BSat.
He's on the right.
With Mr. Izumi and Mr. Thompson. And here is the RCUA of the flight, Mr. Jean-François Lemonnier.
RCUA is what?
The RCUA is a person responsible from the commercial directorate for each customer. So in this case, we have an RCUA for the whole flight, which is Mr. Jean-François Lemonnier, and a deputy, which is Michael Kalari, which is...
Fifth launch of the year tonight for the Ariane family. The second Ariane 5 to go up. The seventh commercial flight of the Ariane 5, the new vehicle. Ariane 5, of course, twice as heavy, twice as powerful and more flexible than the Ariane 4. The idea was to have fewer engines and more lift, more reliable, all lower cost. Coming up now in the 1 minute mark, you can see all is green. We're on time and we're on target. You will hear the DDO.
Tous de DDO, attention pour H0, moins 1 minute.
He'll call out the 1 minute mark.
Top H0, moins 1 minute.
All right, there we are. We're into the final 60 seconds of this final countdown. You're watching Ariane Space Flight number 142. We'll be lifting 4.5 tons roughly of payload, Artemis and BSat-2b. In the back, you see the people. They're not going home, folks. They're going out to the terrace outside because they're going to be able to watch the launch and get a much better view than from in here once Ariane has cleared the tower. So enjoy the liftoff, everybody.
À tous de DDO, attention pour la décompte finale. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Image EAP.
Well, she has emerged from the clouds, and you can see the EAPs, those are the boosters burning, those are the two outer points of light, as Ariane roaring up towards her destination, pouring out each of those EAPs is 600 tons.
La trajectoire est normale.
DDO is saying that the trajectory is normal.
Well, each EAP is 31 meter high. They weigh 278 tons with 238 solid propellant, 540 tons of thrust at liftoff, and a maximum of 600 tons of thrust.
And that thrust is 90% of the total thrust at liftoff coming from those two
La
boosters.
trajectoire est normale.
Normal
Tous les
trajectory.
paramètres sont normaux.
Everything fine on board, the DDO says. That's the boosters are 20 times the boosters on the Ariane 4. Now, Ariane is not coming back to she's not making a circle in the sky. This is the camera that is turning. She rises and then tilts over, makes what is in effect a 90-degree turn. Yeah?
That's right. Well, it has to clear the launch pad and the tower.
Tous les paramètres bord sont normaux. La trajectoire est normale.
Then it will take the best optimized trajectory. It will turn so that it will optimize the radioelectric coverage so it can be able to send all the data back to Earth, and also to respect all the structural constraints that it will have during flight.
750 tons of mass at liftoff, Ariane 5, making her way up after 2 minutes. The boosters should be burning out shortly, and with the weather being what it is, you'll be able to see that burnout.
Trajectoire normale. Tous paramètres normaux.
And you'll see those boosters separate.
There we go.
And there we go.
This should be the burnout.
Séparation des EAP.
DDO has just called out the separation. You'll see that a little more clearly in a moment. You'll see them fall away.
Well, it's a wonderful evening. You can see very, very well. There we have the two spots on the side, which are the boosters separating, and the spot in the middle, which is the main cryogenic stage continuing on its way.
And they are going to fall back into the Atlantic, aren't they?
That's right. They will fall back into the Atlantic.
Are they going to be recovered ever?
It does happen, though.
Bord normaux. Trajectoire normale.
We do recover them every now and again, but it's to analyze their functioning to see if they went well, they burnt well. But we do not recover them so as to reuse them.
Ariane now running on the power of the main cryogenic stage, which is called the EPC. That's going to burn for roughly 10 minutes. That's the spot in the middle.
Séparation de la coiffe.
And we have just lost the fairing, which means the fairing is
Tous les paramètres bord sont normaux.
what protects the upper spacecraft from the dense atmosphere. So once the launcher is up out of the atmosphere, there is no longer need to carry the 2 tons of mass of the fairing, since we no longer have to protect it. So we get rid of the fairing.
Using a short fairing tonight, which is what, 12 meters by 5?
12 meters by 5. For the long fairing is 17 meters.
The long fairing coming up for Endosat, I guess, huh?
Yes.
Yeah. We'll talk about Endosat at the end of the show, folks. Give us a rundown on the curb before we go to the launcher campaign, which is coming up in like 15 seconds. But on the lower left-hand corner of the screen, you have T moyenne SAV. Wait, we'll come back to that because we're going to go to the launcher campaign now. And I think it's your own comment on this one, huh?
The lower composite of the Ariane 5 launch vehicle, that is, without the upper part containing the satellites, is assembled in the launcher integration building, the BIL. Its first element, the main cryogenic stage, or EPC, arrived at the CSG by boat from Le Havre. It was removed from its container, erected and positioned on the launch table. The EPC is built by EADS launch vehicles. Its motor, the Vulcan, was conceived and built by Snecma. Next, 2 solid boosters, or EAPs, are brought into the BIL. These boosters are built in French Guiana by Aero Propulsion. Once the boosters are positioned on the launch table, the EPC is lowered on them and assembled on the EAPs, for the boosters support the whole launcher. The Vehicle Equipment Bay, or VEB, is hoisted on top of the main cryogenic stage. This is where the launcher's electronic equipment, the vehicle's brains, are housed. The VEB is built by Astrium. Ariane 5 lower composite is completed by the integration of the Storeable Propellant Upper Stage, or EPS, with its Aestus motor. It is built by Astrium. Once the lower composite has been completely assembled and checked on the launch table, it is ready to be transferred to the next building, the final assembly building. There, the upper composite, or part of the launch vehicle that contains Flight 142 satellites, will be assembled on the lower composite.
La trajectoire est normale.
All right, briefly, the bottom left-hand screen, on the bottom V, Jacques Rossignol, Ariane Space DG.
Well, briefly, what we have there is the altitude is the A, and the V is the speed of the launcher at that moment, and the curve is the ideal trajectory. They are showing us our clients. So we have on the left Mr. Enrico Segese, the General Director for Space Engineering, Maurizio De Magistris, Alenia Spazio, and Mr. Paul Ariane. And on this side, on the right, we have Mr. Hashimoto, Mr. Watanabe from BSat, and from Hashimoto is the General Director from NHK.
We're coming up to the extinction shortly of the main cryogenic stage, the EPC, which will mean roughly that half the mission will be over. The Ariane 5 basically in two composites, as they call them, a lower composite, which is the boosters in the main cryogenic stage, and the upper composite, the EPS motor.
Il reste de 3 minutes de propulsion pour le PC.
And the satellites. The DDO has said we have 3 minutes more to the EPC burn. Focus.
Tous les paramètres bord sont normaux et la trajectoire est normale.
Everything's fine, he's saying. The focus will begin on the satellites. The curve on the upper, some of the boys from Orbital there, it's Tim Hemke on the left. We'll be hearing from him in just a moment. The cursor coming up the curve on the upper left of your screen is what exactly?
Well, it's the ideal trajectory of the launcher, and the cursor that's going on the screen is the position of the launch vehicle, of the launcher at the moment. So on one side, the vertical is the altitude, and the horizontal line is the distance it's doing.
Okay, and the speed on the very bottom left, the V, the velocity, 5 kilometers per second. That's roughly half the speed we need to inject satellites.
To inject the satellites in this orbit, we need 9 kilometers per second.
So we're better than half.
Well, it's around 9.
Tous les paramètres bord sont normaux, la trajectoire est normale.
The satellite, the launcher, I should say, currently being tracked by the
Acquisition par la station natale.
by Kourou, and we have just had the acquisition from our first downrange tracking station. You can see it on the map there, right over the border in Natal in Brazil. It's a station run by the Brazilian Air Force. Ariane tracked by 3 or 4 stations as she makes her way in about 15 minutes across the Atlantic. The next station being out in the Atlantic, Ascension Island.
Tous les paramètres bord sont normaux, la trajectoire est normale.
And the final station will be in Africa at Malindi. We'll have more to say about Malindi a bit later. We're coming up. We're waiting for the extinction of the EPC and the separation of the EPC, which will be dropped just like the boosters were.
And
we are
Il reste 30 secondes de propulsion APC. Tous les paramètres bord sont normaux et la trajectoire est normale.
All right, about 20 seconds to go to this first burn, roughly the first half of the Ariane mission. You'll hear the DDO call out extinction of the EPC.
Perte normale de la station de Kourou.
See the cursor on the top left crawling up towards it. I don't know if you can read it. It says SEP, that's separation.
Extinction APC.
There's the burnout of that stage.
Séparation APC.
And there's the separation.
Allumage EPS.
And the EPS, which is the upper stage with 1 engine, has just been ignited.
so
Now,
the EPS is nested inside the VECO equipment bay. It has 11.7 tons of propellant and a small IS-2 motor which will push for 1,000 seconds. It will push 2.9 tons all the way to give all the speed it needs to be injected.
And meanwhile, what's happening with the EPC? That's going to fall back into the drink into the Pacific. It's going to make about a half turn around the Earth and fall somewhere near the Galapagos Islands.
Well,
Yeah.
we don't want the EPC to remain in orbit and clutter up the low Earth orbit. So what we would like him to do is to fall down. So we make him fall into the Pacific Ocean. To help him do it, and so we're also sure that we won't have an implosion and more debris in space. we open a hole in the liquid hydrogen reservoir. This hole will help it put it in with spin, and it'll help it fall into the Pacific Ocean in an uninhabited area of the Pacific Ocean.
Tous paramètres bord normaux et trajectoire normale.
Is that what they mean by passivization?
That's what we call the passivization.
Which means you're basically emptying the fluid.
You're getting rid of all the liquid hydrogen, so whatever happens, the liquid hydrogen and the oxygen will never come in contact with each other.
I think that's Philippe Couillard of EADS launch vehicles. The EPS is going to burn 15 minutes. And the onboard computer, which is in the vehicle equipment bay, will shut it down. The computer will determine the right orbit has been achieved. So this is all automatic. We're flying, as you can see by the figures on the lower left, coming up on 8 kilometers per second. We are approaching satellite injection speed. We are 258 kilometers up. And we're in the middle of the EPS burn. You want to go to the quiz? We got time?
Yes.
All right, we have just a little time. Those of you who follow the broadcast know right about this time we...
Acquisition par la station d'ascension.
All right, we've gone into our acquisition of Ascension Island, that's out in the Pacific. We're going to go also to the first of 2 films on the Artemis satellite, and we'll be back with the quiz.
Artemis has been built by 40 different companies from all over Europe, with Ariane Spazio from Italy as the prime contractor.
Launching a satellite is expensive, so we always try to qualify as many functions, as many technologies as we possibly can, so that European industry can have those qualified elements available for commercial applications.
Launched from Europe's spaceport in Kourou, French Guiana, Artemis will remain in geostationary orbit high above Europe and North Africa. The satellite's mobile payload will ensure seamless voice and data coverage, bringing mobile communications to previous network black spots. Users can combine Artemis's improved mobile communications with its sophisticated new navigation system. This will increase the accuracy of GPS signals, making them reliable enough to guide ships into harbours and commercial aircraft to their landing runways. Pictures from low-orbiting spacecraft such as ESA's Earth observation satellite EnviSat and France's Spot 4 will be transmitted by Artemis. Radio and laser beams will be used to send images of remote areas on Earth. Artemis also allows scientists in Europe to continuously control and monitor experiments on board the International Space Station, regardless of its position above the Earth.
The ESA plans for the future will address 3 key issues which are very close to the market and very close to the society. One will address the mobility of citizens, provide them means to be reached and reach other people wherever they are. The other one is an interconnectivity between space systems and terrestrial systems. And the third one is integrated applications, which is for the first time giving telecommunication services together with information coming from navigation and Earth observation services.
Once in operation, Artemis will change the face of satellite communication and demonstrate ESA's capacity for developing state-of-the-art technology for the world market.
Everything's still going according to plan. Up there, you know a little bit more about the Artemis satellite. We've got another film coming up for you. It's a short interview with ESA's mission director for Artemis, with Gotthard Oppenhauser. And plus, then we'll have some more images of that campaign, that satellite campaign. Then we may or may not get to the quiz, depending. But before any of that, take a look at Mr. Oppenhauser for Artemis.
Perte normale par la station natale.
In a few minutes, Artemis will begin its 10 years orbital lifetime. Artemis is a communication satellite of the European Space Agency, and it has 2 main purposes. The first is to demonstrate in orbit some new technologies which will render the performances of future satellites more economic. One of the technological new elements is the ion propulsion system, And this system allows to maintain in north-south direction the position of the satellite during 10 years with only 40 kilograms of xenon. When the satellite will have reached its final position at 25.5 degrees east, a series of communication tests will be performed. In about 3 months from now, the satellite is then ready for the operational service. That means the data relay payload will be offered to Spot 4, it will be used by NVSat, it will be used by several Japanese programs, and we are considering also to provide a data relay service to the International Space Station. The mobile payload will be used by Eutelsat for mobile communication services in the whole of Europe. And the navigation payload will be made available to the EGNOS program. The overall payload will operate for at least 10 years in orbit, and the users intend to use it during the whole lifetime operationally.
First of two. All right, a big night for the ESA people, of course, and for Linea Spazio. But we have another customer.
Yes, so I think we shall sit back and look at the little film on BSat-2b.
That's the first of two coming up, and the second will be, as promised, an interview with Tim Hemke, who was the campaign manager. So the first of two BSATs coming up.
Orbital Sciences Corporation, one of the world's foremost space companies, providing innovative technologies to unlock the commercial potential of space. Orbital's key products, satellites, rockets, sensors and electronic systems, and satellite ground systems are the building blocks of space networks. Orbital is also involved in providing space-based high-resolution Earth imagery and data communication services to industrial and consumer markets worldwide. Orbital Space Systems Group is a primary supplier of low Earth orbit satellites that perform communications, space science, remote sensing, and technology demonstration missions. The nearly 90 spacecraft we have built since 1990 have amassed hundreds of years of successful on-orbit operations, a testament to the reliability of our satellite designs. And with our Star 1 and Star 2 platforms, Orbital has emerged as a major competitive force for affordable, lightweight GEO satellites for direct-to-home television broadcast, cable television broadcast, broadband and wireless communication services. Orbital Star satellites are lightweight 1,300 to 2,500 kilogram class spacecraft that offer a wide variety of payload options, accommodating up to 42 transponders and up to 4,500 watts of payload power. Star satellites are an attractive alternative to larger, more expensive GEO satellites offered by the industry's traditional suppliers. Because they are significantly less costly to acquire and launch, Star satellites are ideal for customers in the early stages of building their businesses, or for established companies that wish to add capacity to their networks. BSat-2b builds on Orbital's heritage of geocommunication satellites. The satellite, along with BSat-2a, launched in March 2001, and Indostar, built for Media Citra Indostar, is based on our Star 1 design. The N-Star-C mobile communications satellite in development for NTT Docomo and a recently awarded C-band satellite for Pan Am Sat incorporate Orbital's next-generation Star 2 design. BSat-2b will serve as an on-orbit backup to BSat-2a that is already providing digital direct-to-home television to Japan from 110 degrees east in a geosynchronous Earth orbit. Both 1,300-kilogram BSat spacecraft feature 3-axis stabilization. Each generates over 2 kilowatts of electrical power and feature a 130-watt high-power KU band digital TV transmission repeater. The spacecraft have a 10-year design lifetime. BSat's choice of orbital star satellites proves that good things come in small packages, providing the flexibility and reliability that today's satellite broadcast service providers demand. Orbital, the leader in small space systems that bring the benefits of space down to Earth.
Right, the benefits of space down to Earth. And down here on Earth, we're at 8 kilometers per second, moving steadily toward the necessary speed of 9 and some for injection of BSat and Artemis. Artemis first in the upper berth, because we always launch the largest satellite first, is that right?
That's right. And this is David Steffi, by the way.
Acquisition par la station de Malindi au Kenya.
All right, we've been picked up by the Malindi station. You can see that on the screen. That's the last one. Malindi will be seeing the extinction of the EPS and both satellite separations. That station was upgraded for the Ariane 5 program and is operated by the University of Rome.
The BSat-2b and previously launched BSat-2a satellites will provide the first direct-to-home digital high-definition television to millions of viewers throughout Japan. Built by Orbital Sciences for the Broadcasting Satellite System Corporation, these spacecraft will relay television channels at a higher resolution and in a wider screen format than traditional analog systems. The BSat-2b satellite will be co-located with its twin, the BSat-2a satellite, at 110 degrees east longitude. The BSat-2a was launched on March 8th and is currently providing television service. BSat-2b will act as an in-orbit spare. The BSat-2b spacecraft weighs 1,300 kilograms. The spacecraft design lifetime is over 10 years. The payload is a fully redundant 4-channel digital TV transmission repeater. The spacecraft generates 2.5 kilowatts of power. Propulsion consists of a liquid hydrazine thruster system and a solid apogee kick motor system. The launch vehicle for both the BSat-2A and 2B missions is the Ariane 5, chosen for its high reliability and excellent value. On both launches, BSat-2 was co-manifested in the lower payload position. The Ariane 5 rocket has demonstrated its robust design by significantly improving the BSat-2 separation orbit, thereby increasing spacecraft lifetime. Orbital Sciences Corporation manufactures low-cost space systems, including satellites, launch vehicles, sensors, and electronics. Orbital is also involved with satellite-based networks that provide wireless data communications and high-resolution Earth imagery to customers all around the world.
All right, now you know everything there is to know about our 2 passengers. We have about 3 minutes more to the EPS burn, and then we'll start looking towards the satellite separation. We want to mention a couple of particularities to this Flight 142 tonight. First of all, it's the first time we've launched in July since 1996 for some reason. Did you know that? Flight 89 was the last time that we launched in July. Arabsat and Turksat. Thought I'd mention that anyway. But more important, we have more perigee and less inclination. Those are some of the other important features. Maybe you could give us an explanation of what that means.
Well, we had a little bit of an extra performance on this launch vehicle, so we were able to have a higher perigee. We were able to raise it from 560 to 800.
And why is that important?
Well, that's important because it will give the spacecraft a much longer life. It will use less energy to round its own orbit to geosynchronous orbit.
So it's a closer delivery from the Ariane because of the Ariane 5.
Exactly. And the other thing is that the inclination of the orbit is smaller, so for the same reason the spacecraft will have to use less of its own energy, its own fuel,
Normal par la station d'ascension.
so that it won't have to correct his plane as much, and that will be a longer life.
I think Tim Hemke, whom you just saw in that interview, said earlier that they gained half a year of life on BSat-2A because they used the same technique. It's not the first time they used the technique, but they used it for BSat 6 months. That represents a lot.
Yes, and it's not the only place where we've given them a better service. We've also made the combined operations, which is the last part of the campaign, shorter by 1 day, and we're working on to make it even shorter. We must say that after the 7th commercial launch, we are now at a 30-day campaign, whereas in Flight 50, which was a
There's the extinction of the EPS, the GDO says.
Yes, so I'll close up fast. So after 25 Ariane 4 launches, we had a 31-day campaign. So after 7 launches, I'd say we have a very good operational maturity.
So continual improvements.
Continuing improvement.
To the program. So what's next? The SCAR sequence, which is where we're spinning up and spinning down after we... What's left of the composite up there? The EPS is burnt out, but it's still connected to the satellites.
So what's left of the composite? We have the EPS, which is nested inside the VEB, the Vehicle Equipment Bay. Inside the Vehicle Equipment Bay, we have what we call the SCAR, which is a system which helps control the attitude of this composite, because now we don't have a major propulsion, we just have this small auxiliary propulsion which will help spin up, spin down, and turn the launch vehicle in whatever direction we would like it to be turned while we separate the spacecraft. We don't want the spacecraft separated exactly in the same position. We want them to be sufficiently far one after the other so they do not interact.
So we have 2 maneuvers because we have 2 passengers, two different ones.
We have more than 2 maneuvers. So here we have Mr. Mastracci. They are now getting close by. We have separation of Artemis, so they are looking at what's going to happen.
Artemis.
There's separation of Artemis. The DDO has just announced.
So once we have separated Artemis, Artemis is clamped on an adapter, an 1194 adapter, and we remove this clamp band with a pyrotechnical order, and we have 8 springs which have separated Artemis. So now we will reorient the composite in another direction, and we will have to eject another structure, which is the launcher structure, which we call the CILDA, which covers BSat. Then once we have moved and we have separated the CILDA, we will have liberated BSat. We will then reorient before we separate BSat. And all this will be done in this phase.
All right, now that Artemis is separated, you might want to know just briefly what's going to happen next to the satellite. The first acquisition will be at that station at Malindi. That'll be coming up in just 2 minutes. Second acquisition in Perth, at the Perth Station, Australia, 17 minutes after that. Then we have the solar arrays, and there are 4 panels. They're going to unfold one first. That's between launch time plus 2.5 hours roughly. And then there will be 3 apogee burns next Saturday, the 14th, Sunday and Tuesday.
Séparation CILDA.
There's the separation of the CILDA, which means what?
Which means that now we will reorient and we will separate BSat-2b, because now BSat-2b can be freed to be separated. It was covered by the CILDA.
All right, we're going to go to a look at the S5 buildings coming up soon, because we mentioned they're going to be inaugurated tomorrow.
Arianespace with ESA and CNES works hard every day to improve conditions for customers. The bigger Ariane 5 launch vehicle carries heavier payloads and so needs larger buildings for those satellites. Halfway between Jupiter Mission Control and the launch pad, these began going up in 1998 at a cost of 75 million euros. Actually, there are 3 parts to the new facilities, A, B, and C, 2 filling halls and 1 preparation hall. Nearly 50 companies worked here. In all, they used 5,000 cubic meters of concrete, 2,000 tons of steel girders, and 12,000 square meters of metal siding to put up 140,000 square meters of total surface, of which 3,800 square meters of clean rooms.
The last couple of years here at the CSG, we've been building some new satellite preparation facilities. These are the S5 buildings. Now, when ready, the S5 buildings are going to afford the satellite preparation crews a lot more square footage, as well as being big enough to handle the new larger satellites coming on the market for Ariane 5. Now, we're here with Didier Cassé, who's Arianespace's mission director, to get the lowdown. Didier, why do we need new mission facilities for the satellite crews here at the CSG?
Ariane 5 payloads are wider and heavier than for Ariane 4. So because of that, we need buildings with doors wider than the one existing now, and also we need cranes with more capacity than the one existing now.
What are the advantages that S5 has over the older buildings?
The spacecraft will stay in S5 during the whole campaign. So we are simpler, faster. We are also faster during filling operation itself, because we have dedicated area for the propellants of the spacecraft. So by using this dedicated small room, very close to the filling hole, we gain also roughly 2 days on the campaign.
Didi, imagine I'm one of these satellite crew members. How is working in S5 going to change my life?
During an Ariane launch, in S3, we have to evacuate the area for the launch. Here in S5, we are out of the forbidden area, so we can keep working during this launch. I think it's much more convenient.
Steve Hall, Arianespace's program director, says S5 sets a whole new standard for customer service.
The S5 facility again caters for the larger payloads, but what it also does for you, it's in effect a one-stop shop. The spacecraft can arrive and do its non-hazardous processing, electrical checkout and testing, and then by rolling from one part of that facility to another on, in fact, an air pallet, you transfer into the hazardous processing so you can fuel the spacecraft. So in this way, we do not have to transfer over large distances across the facility here.
So the S5 is part of the buildings going up for the Ariane 5 program. The Ariane 5 built for bigger satellites, and a couple of recent market studies, I think one of Arianespace's own, proves it.
Well, yes, market studies done in the past have shown that as the years go on, the spacecraft will get bigger and bigger. So, yes, so we have Mr. Izumi who had on the view. Here is a graph which shows you the market, the size of the market, and as the years go on, how the market, the satellites distribute. So as you see, as the year goes on, in 2005, the less than 2,400 kilogram spacecraft tend to get much smaller towards the creation of the more than 5,000 kilogram spacecraft. So that justified the decision to build the S5.
Coming up on separation of BSat, should be imminent. You'll hear the DDO call that out. That's, I believe, James Thompson, the COO at Orbital.
And next to him, Mr. Izumi, the BSat president.
They're waiting for the DDO to call out separation of their satellite. BSat-2b, the twin, to BSat-2a, which was launched back in, I think it was March of this year. Ariane launched all the BSat fleet. I think there were 4 of them.
Séparation BSat.
And there's the separation.
So there we have it, the separation of BSat.
And the applause, and the people were very polite, waiting until both satellites had separated for the applause.
You can see the people very happy now. The Orbital team is congratulating each other.
Six, 5, 4, 3, 2, 1, top. Allumage Vulcain. Image EAP. Tous les paramètres au bord sont normaux.